We've been working on methods to answer questions about videos. Through the past few years, we've developed an approach, it's a generative model, that can connect your high-level knowledge about the world with your low-level perception. So take a sentence like the tall person quickly rode the horse leftward away from the other horse, and the video, and understand, is the sentence true of the video? Where in the video is the sentence true? We've also taken the system and turned it on its head. We can take a video and automatically search for sentences that describe this video. So we've been wondering, if you have a generative model that connects high-level knowledge with your physical perception of the world, what else can you do with this model? And one of the things we've been working on is question answering, as I mentioned. So given a video like this, Danny picked up the pear, he put it on top of the car, and I was just standing there watching him do all the hard work. We can ask a question. What did the person put on top of the red car? Now, what we want to do with this question answering system is do it in some way that's a bit closer to how humans learn to answer questions. You can describe what's going on in videos, but no adult ever taught you how to answer a question. Or any time that you learn how a system works, for example, you learn how your computer works or how your cell phone works, you can answer questions about it without having an explicit training set about how to answer questions in this domain. And that's what we do. We learn to answer these questions without a single training example. There's actually no learning here, and there's only one parameter. I'll tell you about it in a moment. So we take a question like this, what did the person put on top of the red car? And we turn it into a template that looks like the person put the noun phrase on top of the red car. Then we can ask the system, exactly the same system that we had before, recognize this template, show us where in the video this template actually matched well, and automatically fill in this noun phrase for us. So we just use the generation system that we already developed. And so we can take this question and automatically produce an answer like the person put the pear on top of the red car. What's nice about this is, as long as our system can take a video and describe it, we can answer questions about that description. So we could ask questions like, what was the person next to the person that was putting things on top of the red car doing? We can ask questions like, what was the color of the car that the person was putting an object on top of? Questions can get more and more complicated, but as long as we have a description system, we can answer them. The one parameter that we had to add to the system is because question answering is slightly different than description. Description is an easier task. I just give you a video, and I ask you, produce a sentence that's true of this video. In question answering, you have to produce something that's both true and specific. If you imagine that we're in a parking lot full of 100 white cars, and you ask me, where did you leave your keys? And I tell you, I know precisely where you left them. You left them in the white car. That was true, but I'm an asshole. That was totally unhelpful. So what's important, you have to produce things that are true and specific to the question and to the information that the person's seeking to extract. And so that's what we have. We have a specificity term that basically trades off the likelihood that what you're saying is true, because the longer my answer, the less likely it is that it's true. Just every word is basically a constraint on what can be true in the video, against saying something that's specific and actually gives the other person a large amount of information. Thanks. And I actually get to go next.
Okay, Andrei.
Well, hello again. So we've been working on something completely different from what I described before, which is single frame motion segmentation. So the system that I described before really relies on videos. It really wants to see people picking objects up, like chairs, or putting them down. It looks at the motions of the objects in the video. It extracts features from the motion of those objects, and it recognizes actions. But there's an interesting question. You and I don't have to have videos in order to recognize what's going on in the world. We can recognize actions from single frames. But evolutionarily, there probably weren't a lot of photo cameras 200 million years ago when our visual system was developing. So how exactly does this trick work? You never evolved to recognize images. Maybe you never even saw an image when you were growing up. Certainly, you probably never saw images 200 years ago before they invented cameras. And one day, someone took a photo and showed it to you, and everyone could recognize what's happening. So one theory about what may be going on is that you can actually see motion even though there is none. Here's an example of this. If you look at this ball, you can tell me its probable velocity. It's probably stationary. If you look at this ball, you can probably tell me that this ball is moving pretty quickly. So you saw a certain amount of motion in these two frames, even though you didn't see the video. And that's what we wanted to see whether we could reproduce. What we did is we went to YouTube and we got a lot of videos of cars, about 100,000 videos. And we used an optical flow algorithm to label every frame in these videos with its probable optical flow. Then we took a convolutional network. It looks a lot like an autoencoder, except that on one side we feed in the image, and on the other side we would like it to predict the optical flow for this frame. And so given single images, we have the ground truth optical flow. It's not really ground truth because we didn't have stereo cameras or depth cameras. It's just an estimate from some optical flow algorithm. And we can automatically produce optical flow from this single frame rather than from the video. This is a little harder to see for the audience, but you can actually see that there's an outline of a car here. There's actually an outline of a car here. The top example is a little clearer. And now we can do things like single frame motion segmentation. We can take an off-the-shelf motion segmentation algorithm, and it actually finds cars in these videos. We haven't done the action recognition part, but it's in the pipeline. And something else that we want to work on is improving object vectors with this. So right now, the way that you train something like a state-of-the-art convolutional object detector is you feed it a whole bunch of images from ImageNet, and it gives you a whole bunch of classes at the end. But what this system provides is a kind of automatic background segmentation. It can focus the attention of the system on one particular region where the likely object is, and we expect that this is going to improve performance.